Let's continue to calculate probabilities for a distribution that we know to be normally distributed. Imagine that the baking time for a cake with a particular bakery is normally distributed with a mean of 32 minutes and has a standard deviation of 3 minutes. The variation around the mean is attributable to the variation in the liquid content of the cake batter, usually the result of cream content in the milk. From experience, it is determined that the best length of time for baking is between 26 minutes and 34 minutes. This range is asymmetrical because the chef believes customers would rather have a cake that is a little undercooked than overcooked. What is the probability that a cake taken at random will lie within this acceptable zone? This probability problem meets the requirements of a normal probability distribution. The random variable time is continuous, and we are told the distribution is normal. We have been told this, and we have to be told this. There is no reason to believe that baking times are normally distributed. Indeed, there is little evidence that any particular random variable is normally distributed. But we are still in the world of probability, so we know everything, still, well, for a while. The best way to organize the answer to this question is to draw the relevant graphs. So let's begin. We have here the random variable x, which is time. This is normally distributed. We are told that that is true. We are also told that the mean of this is 32 minutes, and the standard deviation is 3 minutes. And I always like to put those up there so I can see what I'm doing. Now, our question is, what is the probability that x lies between, and we have an asymmetrical distribution, 26 minutes and 34 minutes. Okay? And that's our question. So we can put up here 34 minutes, dot, 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 and over here 26 minutes, dot, dot, dot. What we're looking for is this area here and this area here. What we then do is we find our standardizing formula, but we're going to have to do it twice. If we draw our graph, this will become clear to us. This is z, the standard normal distribution. The mean goes down here. Mu is equal to 0. Distribution looks something like this. I bring the 34 down here. This is going to be z2. And I bring this z down here. This is going to be z1. This area here between 0 and z2 is equal to the area between 32 and 34. This area between 0 and z1 is equal to the area between 32 and 26. So we simply have to calculate these. So z1 is equal to x1, this here is x1, minus mu divided by sigma. z2 is going to be equal to x2. This one's x2 here. And so I've got x2 minus mu divided by sigma. Okay? Now, if I put in my numbers, I'm going to get x1 is 26 minus 32 divided by sigma is 3. Here, I've got x2, which is 34 minus 32 divided by sigma, which is 3. And if I calculate those out, then what I'm going to end up with is that I've got this one is equal to 0.606, and this one here is going to be equal to 2. Now let's notice something here. 26 minus 32 is actually negative 2. However, because I'm only counting standard deviations, I really don't care if it's minus or plus. So 2 standard deviations is what I'm going to look up in my normal table. When I go to the normal table, then what I'm going to find here is that the area from 0 to z2, this one here, is equal to 2454 is this one, and this one over here, this is the larger area here, and this is going to be 0.4772. Okay? We've met, by the way, 2 standard deviations, and we know this. Our final answer is going to be the probability of this one, 0.2454, plus the probability 4772. And that's going to be equal to the probability between these 2 numbers, this range here. If we add those things up, we're going to get 0.7226. Our conclusion is a bit disappointing for our chef. It would seem that there is only a 72% probability that a randomly selected cake is in the acceptable zone. This would mean a failure rate exceeding 25%. From our formulas, we can see how to improve the chef's results. If the standard deviation were reduced, okay, from 3 to 2, just 1 point, it would increase the probability. It would increase the z-value, which would increase the probability. The problem at this bakery appears to be the variation in the amount of liquid in the batter, and the blame falls to the assistants who mixed it.